on my imaging radiometer. But if I'm using something that is a bargain one that's come out now that's below $1,500, I'm probably going to want to be as close to it as if I was that mechanic looking at that oil filter. Insufficient temperature difference. You know, some of these cameras have different sensitivities. The one that I use is called 50 millikelvin at a certain temperature and pressure, but basically it's 0.05 degrees centigrade. It can tell the difference. The new camera that's come out, it's 0.04. The first camera that I started out with was 100, which was 0.1 degrees C. Now there's nothing wrong with 0.1 degrees C as long as you're using it for what it's intended to do. Knowledge of when to apply a heating or a cooling source. And adapt methodology, again, used in forensic photography. Stand back, try and get a picture of the entire boat, find something that's wrong, and move forward. It's great for external inspection, but you know, it's kind of limited in some of these smaller boats that we're looking at. You can't really stand back too far because there's a wall behind you or a bulkhead behind you. But still the same thing. You don't need an electron microscope image in order to convert a problem. And when you're trying to explain something to somebody, you need to be able to give them that perspective. That concept of gross to fine, we talked about it in the audio stuff, standing back. Looking at different perspectives. When you're looking at infrared, the best reflection, just like the best reflection in that audio gauge, is coming off that back wall directly at it. Well, you don't always have that chance, so sometimes you have to move and take shots from different angles, but you need to understand the concept behind it, that sometimes radiating energy, if it's not traveling in a straight line, it might be bouncing back and forth in a cavity and focusing, just like that hyperbolic mirror when they were, listening for the sounds coming from the electrical overhead, that dish. You still have that same kind of concept. You have to be aware that if something has a cavity in it and it appears to be hot or a different temperature, it may not really be a different temperature. It may just be the effects of concentrating the radiation coming back. Surface preparation, weather conditions. You know, it's raining. You can't take thermal imaging when it's raining outside, guys. You know, even when I'm doing a boat early in the morning, I've got to wait for the dew to burn off of it before I can actually give a good reading of the temperature. So some general points on interpretation. There are competing factors such as reflections from the background, composition of different materials. You know, you're looking at something that has bottom paint on it. The bottom paint is going to go ahead and show out a different temperature pattern. You might have to scale differently. I'll show you an example. Insufficient temperature pattern difference. I'm going the wrong way again? No, I'm still going the right way. That methodology for forensic, gross to fine, different perspectives, surface preparation, inappropriate weather conditions. Okay, here is my recent project that I'm working on. It's a Katana sailboat. It's fairly expensive. It's a 582 model, a little bit over 58 feet. And it was coming up on a rail, and they had a problem with their first attempt bringing it up. All right, so I'm doing thermal imaging on it, and I need to impress something upon you guys. It isn't just the camera. You need to be aware of software. That's why I teach courses in this kind of stuff. You may buy a great camera, but when it comes to doing the interpretation of the image, you may find all of a sudden that you have to spend $5 grand in order to get research grade interpretation software. Because if I'm looking at this particular boat here, I'm kind of seeing an area where I've drawn this rectangle that looks like there might be a problem. But that's only because I've been doing it for more than a day. But I can do a local adjusting of the temperatures within that box. And guess what comes up? A temperature pattern that's not consistent. Well, an epiphany of the obvious. This is where there was a vertical beam, steel beam, when they put this thing up and tried to do their first attempt at bringing it up, that the boat shifted and it smacked that beam. Well, you could look at the image up here and not really see it, but you can see it with a thermal imaging camera that you know that you need to get up there and start tap, 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 figuring out what's going on. It might be an area where you have to take a core sample. Maybe you want to do something that just cuts the skin and try and break it off to see whether there was a disc bond there. But again, it's the software as well, not just the camera, but what you can use to interpret it. Diesel engine. Well, here's something where we were looking at that oil filter. I drew a rectangle around it, and I got the maximum temperature inside, 186 degrees Fahrenheit. Well, guess what? Same temperature that my mechanic that was using got with his spot radiometer. Also, the needle on that analog gauge up there was showing above 180. And you know, we kind of trust or maybe not trust what we see up at the helm. But the whole point is, you go back to the client, you show them the photo and said, look, mechanic says 186, we haven't been chatting. I'm showing 186. There's a reason why this is running a little bit hotter than what it should be. We need to figure out what's going on. So again, infrared imaging, a little bit better sense of eyes and a little bit better communication tool. Findings. I have a place that you can go out to at one of my websites. And again, you can click on this yourself. And you can see some examples out there of things that I've seen. The P65 specifications, FLIR and most other electronic companies are really great. They do something that's fantastic. But it's sort of like, if we dumb it down just a little bit, will people still buy? If we change its frequency where it's not doing 60 hertz anymore for the image capture, if we can do it to 30, my video cameras and stuff like that, can we still get people to buy it? It's going to cost us less. If we change the resolution, can we still get people to buy it? Yes. So what I'm saying is, sometimes technology that's a little bit older is actually better. There are people that use cameras that are 10, 15 years old, and they swear by them because, not at them, but they swear by them because they're really great, but they don't make them anymore. Just being stubborn. Anyway, if you go to that website, you can see some different examples of how to use thermal imaging. There it is. So, here's an example of that hot temperature. That's 287 degrees here, only because that terminal needed to be turned a quarter of a turn. Those little plastic pens, if you got one. Today, I stuck it in there as a visual spot marker, and when I took it out to take a look at, the barrel was melted. It's sort of like, my God, I guess it really was hot. Wet exhaust system here. This applying a little bit of warm air, not very much, like 5 degrees Fahrenheit, on the deck of a boat. Can you figure out what's going on here? I was at a factory when this happened. They said, well, let me show you what I can do to help you with your quality control. Within probably 2 or 3 minutes, I was scanning the whole deck and I found this. And most boat builders, some of them are concerned about the sides, but they're really a little bit more concerned about the high traffic areas that they're going to break and they have to come back and repair later. Of course, when I found it and showed it to them, the first thing they came out with a hammer and started beating it. It's like, yeah, you're right, I can hear it. Electrical cables, you're just showing areas that probably if I opened that up, when I opened it up, I did see corrosion starting to form on it. Here's the difference between an osmotic blister that had liquid in it, and you can see other ones when they come out in that short haul, if they're dry, they'll be warmer, simply because of changes in thermal mass. This pattern right here, impact. You can see where it got hit right here, it's a warmer temperature, and you can actually see the V pattern of how the delamination occurred. This was an old camera, 100 millikelvin. This is the one that I first started out with. So if you know what you're looking for, if you're there at the right time, if you're using the right temperatures, you can still see stuff. But sometimes it's not so easy to see. Sometimes you might miss something. Okay, we're going to wrap this up with talking about certification guidelines. When you get certified, usually there's a body out there called ASNT, the American Society for Non-Destructive Testing. And there's a guideline that's always recommends saying, we teach this course based upon SNT TC1A. Cool. It's a common standard out there. But guess what? They don't require that you have an application standard. They're certifying that you know how to turn the camera on, turn it off. They're certifying that you know the difference between some emissivities and stuff like that, that you understand the concept. But they're not certifying you saying that you know how to look at an electrical panel. They're not certifying that you know how to look at rotating machinery to see if there's a problem or not. So it's great technology to have, it's a great thing to have, the certification, and it helps a hell of a lot if you're ever called into litigation. You say, well, you know, I've got level 1, I've got level 2, I've got level 3, because people understand that at least you went somewhere to get trained and somebody signed off on it. But it's not the same as the application. People who take the classes and come back and start doing stuff, and sort of like, well, they didn't teach me how to do boats. They didn't teach me how to do electrical systems. Who certifies on this ASNT, SNTC1A? It's the employer. It's the guy taking responsibility. You have infrared people working for you. It's the employer. Or that employer may go ahead and hire an outside contractor to come in and give you that information. It's not ASNT certifying you as level 1. They put out guidelines and they're making sure that the employer follows those guidelines, or the person who's teaching you follows that. It's kind of like Coast Guard, you know, are they actually certifying that fire extinguisher? Hell no. But it's built to a certain specification that it's sort of like, yeah, Coast Guard kind of approved. There are certification levels. ASNT's definition of those levels are: a person who's level 1 performs specific calibrations, tests, and evaluations according to written instructions, and they record the results. So if I'm level 1, then I'm expecting somebody to tell me how to do it, and I'm out there with my camera, or imager in this case, and I'm recording my results. The next one up in the food chain is level 2, and that's required to set up test equipment, interpret and evaluate results with respect to applicable codes, procedures, and specifications. So in the electrical industry, there are codes out there that say, look, you know, it can't be this much a temperature, and you've got to be this far back from a high energy source, and by damn, don't point your finger at something that's high voltage, because it's going to leak to your finger and you're going to be a cinder there. So again, this technology that's coming to the marine industry, it's been around there for quite a while, other people using it. It's just giving us a better set of eyes, a better advantage, a better way to market ourselves that we're picking up on and we're applying. Level 3, oversees the activities of 1, 2 personnel, writes procedures, responsible for training examinations, a level 1 and 2 individuals. Why the hell did I get a level 3? Because I want to teach the course. I want to write standards. I need the pedigree for it. You guys, level 1 at the most, you know, maybe even just a level 1 distance course that you took an exam at the very end and said, I understood the concepts. That's going to work for you if you ever get into litigation. Do you need to be level 3? Hell no. Not unless you're taking responsibility of writing procedures for a company. Trainee, well, you know, there's no rocket science there. It's just a person that's not yet certified. So discussion, again, I'll plug my company, Allinson Infrared Inspection Services. This is the website, baby. I teach a 2-day seminar. The first day of that seminar is going over the standard for fiberglass. Why did I pick the standard for fiberglass? Because it's the hardest thing to do with infrared. The rest of the stuff, electrical systems, machinery, piece of cake. You know, but this stuff takes a little bit more art than science. Infrared Inspection Institute. You'll hear me talk about them. Here's the link that you can hit to go ahead and look at the long distance training. And here's the link right here that you were going to use to go ahead and order standards. If I were you, I certainly would want to be able to use my camera for more things than just looking at fiberglass boats. They have standards there for looking at roofs, electrical systems, air conditioning systems, high-vac systems. This is the only company that I've come up against that actually writes a standard. Everybody else kind of talks and dances around it and gives you different level certification. But this is really a standard to follow. These are the people I hooked up with when I wanted to get a standard out there for people doing fiberglass. Why? Because it gives you guidelines. It tells you how to protect yourself when you're doing it. And at the very least, you can at least reference the document and said, I use the applicable sections of that standard. Again, you can use the standard sitting down with your client. You're responsible for this, I'm responsible for that, here are the deliverables. So what do we do differently? What do I do differently? If you take my course, you do well in it, pass the written exam at the end, I will step up to the plate and I will give you certification for the application. I also offer interpretation services. Somebody sends me a photo, I don't know what the hell this is, Jen, but I took your class and I understand here's the visual picture, here's the thermal image next to it. Can you tell me whether I need to go and do anything more about that? Report review. You know, I've gotten several reports where people have had thermal imaging done and they're looking at it and they say, you know, I'm not quite sure this guy was the sharpest tack or the tool in the shed, or maybe he wasn't. So it's a due diligence service that I offer. Send me your reports, I'll review them. Say, yep, I think he did it right, or no, you know, he was trying to shoot an object and he was a gazillion miles away, trying to give you a temperature pattern. No, it was his face. I could see his glasses, I could see his mustache, I could see his nose. And he's telling you that this is DLAM? Probably not. Yeah, expert witness. You know, I'll get called in to do that kind of stuff. Application standard. You know, regardless of whether you're doing the work or you're hiring somebody, make sure, because the application standards are out there, make sure that you get the appropriate one. And require that thermographer that's working for you to follow that standard, or at least reference it and saying I used everything except part A, B, and C because that doesn't apply to what I'm doing. Here you go. Get the training before you invest in equipment. Man, the first camera I bought, if I had that FLIR camera imager, they'd be happy to train me. You know, and of course that was part of the deal I, you know, struck with them when I was trying to get that cheapest price that I could. But, you know, if I knew that I could have actually gotten training on what I wanted to see before I bought the camera, man, I would have been a much more educated person. The first camera I bought was 18 grand. I called it the yellow flashlight. It didn't have radiographic images, but it was cool. And then a couple months later, it's sort of like, oh my God, you know, this isn't going to stand up in court. You know, I'm taking Polaroid pictures of stuff with no temperature measurements to background it. I'm not doing the right, well, I was doing the right temperature span, but the whole thing about the standard, it shows you how to be able to have your results reproduced. And that's what you need. You need to be able to come in and have everything in there so that when somebody's doing review of it, you know, it's sort of like, yeah, I see what he did, I see what he followed, and man, he's got those radiographic images that have not been changed, and I can actually do the interpretation and say, well, yes or no. So, this company that I keep plugging, Inspection Institute, there's a reason why I do it. These people don't sell cameras. You know, you buy something that is a fluke camera or a FLIR camera or whatever it is, they are selling cameras, and oh, by the way, you get some education. Infraspection, on the other hand, sells education, and they don't really care what kind of camera you get. Their first thing that they tell you is that figure out what you're going to do. If you're going to look at electrical panels, buy the equipment that uses the electrical panels. If you're going to do fiberglass, do something different. But there's a lot of value with hooking up with an organization that believes that you need to be educated. And they'll sell education and they do a good job, and it's not cheap. But for me to spend $2,000 to get a training and understand what I'm getting before I go out and lay $20,000 down, or even the concept of, you know, damn, you can rent equipment, you can get training, you can earn while you're learning. You don't always have to go out and spend $25,000 on a piece of equipment. Line up a job, get the training ahead of time, know what you're doing. And when that job comes in, rent it. Minimum training, level 1 distance course, 15 CEUs. Okay, that came from Kenny about a month ago, a couple of months ago. There's a certain amount of training that you can get distance-wise when you're trying to get your stuff going on. So you may do something like this training course is actually 32 hours long, so it's not, you know, just 15 hours. But it certainly is kind of a win-win situation. You're getting CEUs and an education at the same time, and you didn't have to come to a hotel and spend a lot of money. And you can actually make money doing your other stuff while you're waiting. So the 10-minute breaker conclusion. For those that are interested, I'm going to quickly show, or at least try to quickly show, this concept of burst recording. So this is the P65. This is an image file that is going to be coming up here in just a minute. This is a slow old computer, kind of like me. This area here, 1 to 436, this is burst recording. I have 436 radiographic frames that I took while I scanned the boat. A minute, okay? I can do things like forward and go through. Yeah, I'm not as steady as I used to be, so my hand shakes a little bit. But all I have to do is one thing in the field. I have to get this in focus, because that's the only thing I can't change with software. So say, for example, I go back and I look at some results here, and this is a cool feature of the software because it tells me the date and the time. It tells me the serial number of the camera and the lens and the filter. All these things are required by the standard, so it's reproducible. There's certain palettes in here. So say, for example, and you'll learn about this in the course as well. This is a katana, has dagger boards. Any idea what this is? Dagger board. You got it. All right. Here is chain plate, external chain plate. All right, so yeah, let's take a look in this area. Well, this is a palette that's using an iron gray palette. We'll talk about palettes during the course. But you can set different palettes. And there's a reason why you would want to set different palettes. Because the palettes actually represent different temperature slices. So now I've switched to something that between 107.6 degrees up here in the top and 72.2 on the bottom, there's like several hundred temperature patterns in there corresponding to each one. You can do things like put in a spot, and as I move the arrow around, you see how the temperature is slightly changing from 87 to 86 to 85. Let's go ahead and do this rectangle here. I'm almost done, phone. Okay, so now I'm coming up here and I may do an auto adjust. Auto adjust is basically saying, look at all the temperature patterns or the radiometric images coming away from the object. Give me the best temperature pattern. It shows me 42.6 to 103.5. But here, I'm actually going to do something called local adjust. And now all it's doing is give me the best temperature pattern for inside that area that I'm looking at. There's a lot of really cool things that you can do here. You can do image subtraction, you can do all sorts of stuff for analysis. That's why I'm saying the camera is only part of it. Interpretation is the rest, and having the right tools to interpret with makes a heck of a lot of difference. That's it. That's my presentation. If you're interested in seeing the cameras themselves, come on up.